screen.
It's full screen, and we can see what you're presenting. So please, Christian, we can start.
Okay. Thank you very much for the invitation. I hope that the connection is going to be fine, and that you are going to be able to follow what I'm going to say. So I'm Christian Huyghe. I'm a scientific director for INRAE, a scientific director covering big sectors. So I'm covering all agriculture, which is plant production, animal production, social sciences. And I have a long history with plant science. I am plant geneticist by training, and I've worked on several legumes, chickpeas when I was in a postdoc, lupins for a while, and also alfalfa. So I think I have a little bit of experience on this. And I've been asked to talk about the perspective, opportunities, and all the burning issues regarding legumes in the European cropping system, and how we designed and how we identified the future on that. So what I'm going to first go through is the key challenges. We all share the key challenges, but I think it's better that we all have the same perspective and all the same analysis of that. Of course, the key feature of agriculture worldwide is the production of food. And food has to be sufficient in quantity, so enough. It has to be safe and nutritious, so it's important for securing human life. So a composition that is adequate, absence of sanitary question, and equity. Important is how we ensure that the access to food is equal to everyone, and because a very expensive food is clearly not equitable. And in the middle of that, protein is peculiar, because the protein issue is essential, because compared with all the other elements that are in food, protein are not substitutable. If energy, you can find energy from everywhere, while the protein, the human being cannot create its own protein. And even more, the exact balance of the amino acid has to come from the food. And so the fact that it's not substitutable and substitutable, and the fact that we are not able to synthesize any of the amino acid means that they are very, very special in our diets. The second key and very important challenge is the climate change. To show some of the features is the fact that climate change is due to the level of emission of the greenhouse gas. And in agriculture, in Europe, agriculture is producing 20% of the greenhouse gas. And this is something that is very important. Climate change is really ongoing, is probably the largest challenge that the mankind has faced and is facing today. And it's something that we have to take into a complementary or from two complementary positions. The first is that climate change is a threat for agricultural system, because it puts the climate change, the agricultural system under pressure, but also because of the very high contribution to greenhouse gas, agriculture has to reduce its contribution, so it has to reduce the emission of greenhouse gas, and we have to take both sides. So both at the same time, how we mitigate and how to adapt. And you will see that the legume have a very, very important role to do on that because of the nitrogen. And these are very, very simple figures that are known from everyone of the various scenarios of climate change. And you will see here the figure of as you will have all the slides afterwards, you will see where are the sources of greenhouse gas, and this is to show that agriculture is really peculiar regarding the contribution, the emission of greenhouse gas. For most of the other economic sectors, the main greenhouse gas is CO2, while in agriculture, there is a little bit of CO2, a lot of methane, and really a lot of nitrous oxide. And this puts agriculture in a very peculiar situation. I will get back to this later because I think it's really something we have to address in a very, very committed way. Third element is the biodiversity restoration. Biodiversity has to be considered as a public good for today, public good for the next generations. And we have to take this on board. With the peculiarity is that what is putting the biodiversity under pressure is the agriculture in the agricultural land, but also agriculture inducing land use changes because of variation of the cropping system, expansion of the agricultural area, conversion of grassland into cropland. All this is really something we have to take on board. And one of the key elements is that the agricultural practices per se are really important, and especially pesticide, because pesticide have per se a direct impact on biodiversity and the diversification. So it's quite obvious that when you introduce legume in a cropping system, you have a diversification, but at the same time, for instance, the grain legumes in Europe have a high level of pesticide spraying and very high intensity of use of pesticide. And these are data that you all know from Kaspar Roman showing the decrease in biodiversity was minus 75% of the biomass of insect in 25 years in the so-called protected area in Germany. And this is a synthesis by Sanchez Bio 3 years ago showing the various sources. And this is a very, very exciting work that he have done. What is also important is this data published by a consortium led by Clelia Siramis, showing that the various components leading to a reduction not of the biodiversity per se, but of the trophic chain, so the length of the nutrition chain or the trophic chain, and so what insect is eating which one. In fact, there are three major elements that are the crop diversity, the semi-natural cover, but also the mean field size, which shows that it's not simply the crop you are using, the way you use it, but it's also the structure of the landscapes. It shows that things are never very, very simple. So this was the third item. The fourth item is the air and water quality. I will not talk long about that. It is something that is very important, is the ability to work tomorrow. And the last one, but is also essential, is the economic issues. And affordability and equitability relates to the first item on food, but also competitiveness of farms and of processing industry is something that is important. And there have been plenty of papers on that showing that if you introduce a new crop, a grain legume, for instance, if it is not viable for the farmers or for the processing industry, nothing is going to happen. And the last element that is something that is important to my mind is the fact that we must not only talk about the competitiveness in average, but we have to take into account the resilience to every perturbation, resilience to economic perturbation. What is the effect of variable markets on other commodities, but also variation due to variation among years related to climatic element. And if a cropping system or one crop in a cropping system is not resilient to that, is not going to be adopted by the farmers. So these are the key challenges. And in fact, the legumes are clearly addressing most of these elements of the agri-food system of today and of tomorrow. But from this global picture, we must have some elements to better understand the role of the legumes for today, for tomorrow, and for the type of research we have to address for tomorrow. The first one is, at the very heart of that is the human diets. They are a central issue, of course, for food security. But when you, and I will give you some details later on, is what is the share of the plant proteins in the human nutrition? And And this is something very important. It's at the very heart of the transition in human diets. And that is very, very complex to analyze. I will just give you some brief items, but we can talk a little bit more about that in the discussion. You will see that the legumes are only producing a very, very small share of the proteins that are used for human and for animal nutrition. We tend to very often, and in too many cases, we tend to have a direct connection between legume proteins and human and animal nutrition, but it is far more complex than that. The third element, this for me, the way we should in the future introduce and analyze the story is the fact that protein is only one form of reactive nitrogen. And as a consequence, we must analyze the legume issue by considering together protein and analyzing the connection between all that. And this leads to the idea that we must build nitrogen budgets at the very scale. So you will see some very, very complex graphs coming in. And just to be, is not to reassure you, is the fact that we all dream of simplicity, but for protein is not exactly the case. In fact, it is complexity that is at our rendezvous today. Protein and human nutrition, as I said, it's a central issue. So it's very important to understand what is the quantity of protein we eat and what is the determinant of that. On the right here on the graph, what you see is one dot is one country for two traits. The first one is the quantity of protein per day, and the second is the share of plant protein in it. So when you are here down here, there are less, the proportion of plant protein is lower. So it means that the rest is animal protein. And when you are up here, it means that you eat more protein per day. And this is related to the individual income of a country, so the global income divided by the number of inhabitants. And worldwide, the total quantity of protein we eat is increasing with our individual income on average at the level of the country. And the second is that the proportion of plant protein is decreasing. So it means that the proportion of animal protein is increasing. And one of the points behind that is that we have to understand the economic process that is behind that, but also the societal acceptance of agricultural practice and of production systems. So we have to consider both sides of that. And when I mention animal protein, because here, in fact, you have the quantity, and here you have the proportion. So you could say, okay, if you have 100 gram here, 40% of plant protein, it means 60% of animal protein. You are happy, but we must convert animal protein into the equivalent of plant protein. So on average in the world, this is the quantity and the share of the animal protein. So it's on average 31 grams per habitant and per day, per person and per day. And this is a share. So it's fairly balanced between the various classes. But when you convert this with efficiency of conversion, so the efficiency of converting 1 gram of plant protein into 1 gram of animal protein, of course, when you produce red meat, is far less efficient than poultry meat and far less efficient than milk. And if you turn this, it's not anymore 31 grams, but it's 112 grams of plant protein equivalents per habitant and per day. And this leads to an average conversion efficiency slightly above 3.5. This is using the efficiency recorded in Europe. And I will come back to this later on because you will see that you will figure out that there is discrepancy with other major budget that I'm going to present in a minute. But this is very important. We tend to forget about this conversion. For doing this, we use various sources of protein. And again, grain legumes, we are in an international webinar of the International Legume Society. But we must have in mind, we must be aware that the grain legumes And even together, all the legumes are only a minor source of protein that are produced and used either in Europe or in France, and more generally in the world. And the various sources are grasslands and forage crops, you will see in a minute, cereals, oil crop, and another crop such as in other organizations such as relay cropping. I will not develop that. But these are the data for France. I've been too lazy for doing this for other countries, but the share is more or less the same all over Europe. And you see this in million tons of protein per year. That's here at the bottom is the grassland. It's close to 9 million tons of protein available from the grassland per year. Close to 4 million tons of protein coming from the cereals, 1.5 from the oil crop, 1.5 from the imported soybean, and only a little bit from the protein crop. So we must have this in mind, and I will explain especially the elements regarding cereal. But before going to the cereal, let's talk a little bit about the forage. Again, this is for France. You can do this for all the balance for all the countries. In fact, there are the very source of protein coming from grassland and forage crops. This is from annual forages such as silage maize. This is pure alfalfa. Again, this is the only pure stand of legume. Then you have the temporary grasslands and the permanent grasslands. Temporary grasslands are used very, very often, and it's more and more often the case is a mixture of grass and legumes. And permanent grassland is very complex swards where you have very little legumes. So, and you see, when you see this and you make the balance of the total quantity of protein that are used by the ruminants and the live, so coming from soybean, these proteins account for less than 50% of the total protein coming from the forages. So you see, the key point for balancing the food diet and the feed diet is by considering the whole budget. So what is very, very important, and maybe this is something we have to talk more about when we consider legume and the role of legumes, is to see how they can contribute, not as only producing protein per se, but how they can contribute to increase the protein content of the wool biomass. And when you do this, of course, in grassland, you will have the pure legume sward, but by mixtures of grass and legumes, you increase, or we increase, or the legumes, especially the legumes, are increasing the protein content of the grasses by all the qualities and the properties of the mixtures. And what is also very, very important is how we can increase the content of cereal, the protein content of the cereal. Of course, this is one of the key stakes of the nitrogen fertilization, but it's also something we have to think about rotation. And wheat after alfalfa, for instance, shows a very high increase, a significant increase in protein content. Wheat pea mixtures have been shown, especially by the work of Godin, that they were really promoting the much higher level of wheat protein, and also protein that are cropped on living mulch, living mulch being either alfalfa or clovers. And all these elements have to be considered. For instance, if you take France, there is quite a large agricultural area. If you would manage to increase by 1 degree, 1 percentage points, the protein content of the wheat, this is the equivalent of 2,100 hectare of fodder peas. So this is just to show the balance. So we have to think all the possibilities. And the peculiarity of legume is that we have a huge diversity of species and a huge diversity of cropping system. We can harvest them as grain, as hay, as grazed biomass, and also we must not forget about these vegetables. These are French beans. And also they are cropped in different ways, either pure stand, mixtures, I already mentioned that, companion crop or living mulch. and also agroforestry that is emerging, and that is also providing a lot of services. If I'm going one step further in order to establish a global analysis, this is maybe a bit complex, but I'm going to explain. In fact, I said protein and nitrogen is something that we have to take into account, because protein is one of the situation of reactive nitrogen. There are plenty of non-reactive nitrogen. Is the nitrogen that is in the atmosphere is N2, extremely stable, completely inert. And in fact, in the biosphere and the hydrosphere is only reactive nitrogen, so it's not N2, but N something else, with the very reduced level of, so the negative level of oxidation. You have the protein, the amino acid, the ammonium, the level is -3, and you have the rule range up to +5 when you have nitrate here, nitrite here. And the molecule of nitrogen are flying around this and moving back to the atmosphere with one peculiar item, that is that one, the nitrous oxide coming either from nitrification process or from denitrification process up here. And this is a net because the global warming power of this is 300 times the one of CO2. So we must analyze all that, and legumes are going to play down here. This is a second simple figure. I borrowed this from Gilles Bilen, who is a guy from the University of Paris, who created a mechanism to show global balance of protein and nitrogen. So he's converted every protein or nitrogen as in an equivalent nitrogen. And this is for the world in 2009. This is the initial figure. And if you have want the data for 2020, the total the volume of nitrogen fertilizer that were 98 million tons of in 2009. In 2020, it was 118 millions. In terms of quantity that is absorbed by human population, it was 31.2 in 2009, and in 2020 is 36.6. Doesn't make a large difference. So let's skip, or let's stick to the 2009 data. What you can see there is the fact that what is entering as nitrogen is what is coming from nitrogen fixation. It's 29 million tons. What is coming from synthetic fertilizer is 98 million tons. Atmospheric deposit, that is deposition that is due to the atmospheric reaction. And you see all that. What you see is what is getting out of the process, either from the cropping area, where you have the grassland and the associated livestock production, the cropland, and all this toward the hydrosphere, 95 million tons of nitrogen. And from the human population, where we have 31.2 entering, 31 is going to the hydrosphere. So what you see is that is the nitrogen and the protein cycle at the world level is completely an open cycle. So there are leaks everywhere. This is the first element. The second element that is very important is that at every moment you apply fertilizer that are either organic or mineral fertilizer, a small share is lost as nitrous oxide. And due to the very high global warming effect of this, with 1.5 million tons of nitrogen being lost as nitrous oxide, this is the equivalent to 700 million tons of CO2. And this explains why even though they are changing rates, but it's nitrous oxide is about 50% of the greenhouse gas produced at the world level. And so you could say, but and this is an element that we are very often hear, is that a bit of greenhouse gas is coming from the use of nitrogen. And if you use the nitrogen, the process of nitrogen fertilizer production and the efficiency. In fact, this only accounts for 63 million tons when you have close to 100 million tons. So this is why I was talking about the climate change and about this crucial element, something we have to address very, very accurately. The next element I would like to point is that one. In fact, every time you change the diets, you have a huge impact on this element. And the last one is at the world level, the extremely low efficiency of the animal production. From 132 million tons of nitrogen as feed, as protein in feed, only 11 is produced as an animal. This means that the efficiency is very, very far away from the 3.5 I mentioned earlier. In fact, there are several elements behind that. The first is that I said, okay, I'm going to use the efficiency in Europe, and the efficiency of the animal production is not the same everywhere. The second element is that in many, many sites in the world, animals are doing something else than producing. And even if you feed when you feed a horse for your pleasure, the efficiency is 0. And the last element is that this is what is offered, is not exactly what is eaten by the animal. And clearly, this is why it is so important to pay attention to the losses. Oh, yes. And on this graph, Bilen is also very pointed that this international trade is playing a key role. In volume is not a lot. In practice, it has a huge impact because you create a kind of deficit of nitrogen here, and by transport, you create an excess here. So you create unbalance in both sides. And what I wanted to document here is that over the last 50 years, so it's ending in 2010, but in fact, what has increased a lot is first, initially it was the cereal, and in the recent decades is really the soybean that is today the major trade of protein. And you can do the same balance everywhere. It's very important to accurately measure that, because you can identify from a given territory how you can adapt the production in this level. I don't know if I'm maybe a bit too long, but I'm getting a bit closer to the end. If I try to measure, to show in another way what we can do with our legume for this global budget. Again, we have plant protein. They are used for human nutrition, animal nutrition, but they are later used for human nutrition. A little bit of non-food technological use, but the volume is very, very minor. And we get this plant protein from protein-rich stuff. This is very often the summary we make, or the shortcut we make. But coming from oil crop, from grain legume, for cereal, either alone or mixtures, forage should be a major arrow. We must not forget that one way of increasing the efficiency of animal nutrition is by the use of synthetic amino acid to improve the balance of among the various amino acids. All these species are coming from the crop in rotation and from the grassland. And this is where we have the legumes, at least in this one unidirectional presentation. And then once you have the animal nutrition, oh yes, and we import the protein here. We also import energy from outside through the fertilizer. They are exogenous to our cropping system and our agri-food system. And then we close the cycle by the animal manure, organic residual product that are then getting back to as nitrogen sources. We are also losing ammonium here, and because of their impact on the quality of air and quality of water, we have to be careful about that. And urban sewage, they could get back here. In practice, most of this is lost in the environment or in the sea. Here we are losing N2O. We are leaching nitrogen here, as I mentioned. And in fact, one of the elements that on which we may also work is about intercrop and cover crop. and this is where little attention is paid to the role of legume as intercrop and cover crop. So all these arrows or these circles are pointing where legumes play a key role. One element we must not forget, and a transversal feature that has to be concerned and considered, is the role of the microbiota. From soil to plant to grain and to human gut, all this is kind of transversal, not working a lot. And when we tend to talk about agroecology, so all the regulations that are taking place in sward, in landscape, or at a farm level, we tend to focus on the plants, but we tend to forget that there is a microbial layer around the plant in the soil that are very connected to our human gut and very connected to our health. I think it's next to I'm getting to the end. So to put all this together, we have to ensure human nutrition, we have to ensure competitiveness, we have to reduce environmental impact. There is no compromise to look among that. We must take all this together. And as I already mentioned, we have to consider a few things, and we have to consider other environmental services possibly provided by legume, especially one thing that is the positive effect on flora, on pest control, on pollinator. And the option, I think, for your analysis and also in the International Legume Society is to think the protein issue at the scale of the agriculture, food, and the whole agri-food system. And this is this leads to a complex situation based upon bioeconomy, agroecology. There are many opportunities that we have to work on, and technology push is something. Genetics, I know that there are many geneticists around the table, but technology push alone is not enough. We must combine this with regulatory push and with society pull. If there is no demand from the society, it's going to be difficult. In fact, legume is quite a nice example of a lock-in situation where, in fact, all the system is more or less happy with the fact that legumes do not play a key role, except you and me. But for the rest of the society, nobody is paying attention. We are clearly in a situation where the system where legumes do not play a key role is this dominant regime, and how can we change that? This is a figure adapted from GILS, and is showing that there are two mechanisms. The first one is to support innovation, and there is innovation, a rupture innovation, or a very disruptive innovation that have to be supported. Changing the socio-technique regime by, for instance, policies, regulation, society expectation. But if you want to go further, in fact, there are several mechanisms, and I will first mention institutional destabilization. Some headache to say, and how the institution per se can decide to change the situation. It has been adopted in the world only twice, not for things that were related to agriculture, but it can be decided if it is a major issue that to change the story. I think as researchers and society of researchers, we have to establish extreme scenarios and to see what we need to change and to achieve extreme scenarios. We have to take on board new players in the game, and especially the large downstream companies have to be on board, especially because more and more they are concerned about their corporate social responsibility toward the environment, responsibility toward the human health. And the last element that has been explained, and quite well explained by Clemens, I forgot his name, Clerks from the Wageningen, is to show that participatory approaches and living labs are really nice ways to change and to unlock a lot system. So I will not go for there. And to further unlock, we must go for this living lab participatory approach. That we in France we have a very nice example that is what we call territoire d'innovation around Dijon, that where in order to ensure sustainable food for everyone, especially the suburb of Dijon with the poor people, there is a global transition from production, from processing down to the school to change that, and this is something that is important. It's also important to have this approach with the new players in the EIP Agri, that is offering an interesting opportunity on which we didn't spend enough time to consider not legume as only production, but legume as a legume and protein as well. And of course, nothing is going to be possible without a strong investment of public policies. And in that case, public research is working as warranted. To conclude, and I think that this is my last slide, protein, legume, protein, and nitrogen, this is a very challenging issue. And for researchers, when something is challenging, it's exciting. It is much more complex than simply looking for new sources of protein or saying, okay, I'm going to diversify because I'm going to include one more crop, or I'm going to breed for new variety. This is too simple. We have to approach the whole story in a much broader way, and systemic analysis are required. And these are some elements, 5 elements related with the system approach. Plant protein must be considered as coming from various sources at local and worldwide level. So not legume only, but the rest. Legumes are among and must be considered as protein-rich crop, but at the scale of the cropping system. We must take on board all the sources of protein in animal nutrition. Protein and nitrogen is at the very heart of the fertility on one side, but of the complex issue of the environmental impact. And, and protein and human nutrition, it's a global challenge. And there are huge transitions to come in the so-called developed area. There is a kind of slow decrease of the consumption of animal protein, and in the developing countries, so-called developing countries, there is a huge burst of the proportion of, and huge increase of the proportion of animal protein. And this is it.
Okay. Thank you, Christian. This is your presentation has been
okay.
Very nice, very interesting. It's actually full of interesting points to be reasoned and to be investigated further. So first of all, I thank you for your contribution. Obviously, if some of the attendants have questions, I will happily give the microphone, but I would start with one question for you. I don't know if you're going to be able to answer on point. I guess on slide 7 you show this very interesting plot correlating the average income of some nation to the fraction of plant protein, showing basically that a rich nation and rich inhabitants of this planet, when they get richer, they tend to eat less plant protein and basically more.
It's a proportion, but yeah, you're right. The proportion is lower, mm-hmm. and the proportion of animal protein is higher. Mm-hmm. And in fact, the point that we are facing today is to know how long this trend will last. Mm-hmm. And especially, as I mentioned, that, for instance, in Europe, there is a trend, slow trend, but trend anyway, of decreasing the proportion of animal protein.
And in fact,
but this is maybe your question.
First of all, if you have, do you know what year is that plot from? What if like if it's very recent or?
No, it's 2014.
Okay, so a few years
so
ago.
it's not so old. It does not change that quickly. Anyway.
Yeah, sure. I can attest, at least from Italian point of view, it's something that is clearly happening. That there is more and more user consumption of what we could call fake meat. So all these plant-based product that can provide protein and are but mainly made of soybean, pea, etc. But through some very complex industrial process. At the end, they don't really look like plants anymore. But it's there's a lot of products or alternatives to milk. So there's a lot of soy milk going on and other any kind of nut milk available, and it's clearly growing, at least from the Italian perspective point of view. In the last few years, basically a lot of product came out, and a lot of product are available in the supermarket. And I would like for you to comment on this, if you think that is
you are right.
or it's going to have a big or small effect.
You are right. The offer is increasing. The data show that in practice it's still a very small share.
Okay.
But it is something that we have to consider in a very attentive way, and not to be careful about, but to scrutinize this very carefully. The reason is that the transition toward these new sources of protein is taking place in the most highly educated population and in the younger generation, which means that they are the ones who are going to lead the world tomorrow. Okay. And so the transition is on the way. But today we are not in a situation where we do measure this at very large level and large scale. But it's clearly something that we have to study and to consider. And it's one place where you see that even there with what you call the fake meat, the share, the place, the room for legume is fairly limited. There is not a lot of legume there.
Okay. Okay. Interesting.
But it is really a transition. It is an ongoing transition. It is something that is very important. We have to pay attention to that. This is why I mentioned the question of the social acceptance, because it's a sociological movement there.
Okay. Thanks. I see raised hand. Paliwal, Rajneesh. Oh, sorry.
Yes. Thank you, Nelson. Yeah. May I ask a question now? Two questions.
Sure.
Christian, thank you for this nice presentation. My question is this, because whatever the relationship you showed in your figures, it is the 1 decade back, I mean 2000 to 2010. And we are now in the another 1 decade has passed, and now the global warming rate is very high, whatever we predicted in the last decade. So what do you think the global warming impact on the relationship you showed in your presentation? And
I'm not sure
how we are going to handle this global warming. I'm saying the climate change impact. Climate change impact on the relationship, whatever you showed in your figures, this is going to this much. Of course, the climate change is going very high, and of course, this will the whatever the impact you are showing, it may be now is the different, not the real, not the.
It's a very good question.
Yeah.
The climate change is the perception we all have, especially in the year 2022, in various situations in the world, is that it seems to go faster than what we were expecting, yes. Anticipating even and this is very, very bad news. What is going to be likely? What is going to be the impact? It's difficult to foresee, but I don't think there is going to be a special impact on legume more than other crops. But there will be an impact. The impact can be in several directions. One is certainly not positive on the yield. The second is the risk on disease and all these elements. But if we take the other way around, so I'm going to talk more for the temperate regions, is the fact that if the temperature is slightly higher, what we see is that the duration, the phenology of all the crop is changing. And for instance, if you take France and Europe, what we call the annual crop that are usually sown in the autumn and harvest in the summer, the harvest is getting earlier and earlier, and it gives possibility to have a next crop in the same year. And if you consider this, we could envisage not to drill after the harvest, but to drill before the harvest. So I mentioned the relay cropping. I will develop this a little bit. Several machinery companies, but also with other research organizations, to what we call relay cropping. I'm just going to describe this in a few sentences. We drill winter wheat in the autumn. On the 1st of April, we are killing with a machine 1 row out of 3. And to replace the wheat, we are just killing, we are drilling with the same machine soybean. Soybean is emerging, and the wheat is maturing. When the wheat is mature, we harvest with a special combined harvester where we have protection below the cutting pieces to protect the soybean. And after harvest, then the soybean is growing. We have done this in farmers' condition, not in trials, because in trial we do not see all the difficulty for the farmers. But when you do this with in farming condition, we are able to have a production in biomass that is 187% of the average cereal on one hand, soybean on the other hand. So it's really a major increase. We are using less nitrogen for the cereal because on the end of the cereal cycle, the legume is doing a little bit of work and the cereal is producing slightly less, so we use less nitrogen. I said 180% of biomass is much higher in terms of total protein. And the last element is that we do not have to spray herbicide on the soybean. While when soybean is grown as a pure crop, we need herbicide and it's quite difficult to protect. The reason is that wheat is in fact protecting the soybean against the weed. And you said, why not doing this everywhere? There are several reasons. The first one is that it is quite difficult to drive. And for the farmers, it's not so easy to adopt that. The second is that for the farmers, it's a risk. And if you tell him, okay, you have drilled your wheat, now you are going to get a machine in that and destroy 1/3 of the wheat, he's going to ask you whether you are drunk or not. And the last element is that you must have machines that are well adapted to that. Especially when drilling, you need a driller, a sowing machine, and you need a GPS to drive you exactly at the right place. And your combine harvester must use exactly the same precision farming equipment, because if you are not at the right place, you do not harvest the wheat and you kill the soybean. So all this means that it is changing. But if you take the story that way, you see that the climate change could offer new possibilities. So climate change at constant farming system is really difficult. If we accept that there is a climate change and that we can change the farming system, then there are some opportunities to take on board. But we know that it's not going to be easy. Sorry for this long answer.
Yeah. Thank you, Christian.
No,
you are true.
Very informative. Thanks. We have another question, another raised hand from Laurent Mercier.
Yes, thank you, Nelson, and thank you, Christian, for this very interesting presentation. You said in your presentation that we need the systemic change, now we have a specific and punctual international crisis, with the war in Ukraine, and the consequence of it is a reduction of fertilizer in Europe because of reduction, of the price of gas and the availability of gas, of course. And then my question is, I guess it offers now, of course, that's not my question, it offers now opportunities for changing the model. But do you think, and that's my question, you would have time enough to initiate some change now? How long would it take to initiate and to have the change to be installed, let's say? Of course, there is probably no scientific model ready to be used to answer the question. No. But what is your feeling about that?
My feeling is that every economic players will try not to change the system because they are more or less adapted to that. And what is interesting is to see that during the spring in Europe, when the fertilizer was increasing a lot, normally due to climate, to economic balance, the farmers should have reduced the level of nitrogen fertilization, and they did not do that simply because they were hoping for the price of wheat to be very high. So as nitrogen fertilizer is an input, and as on the long run, there is a connection between the price of the various commodities. Everyone was betting that they would have a very, very high return. It was not the case because the price of the wheat didn't stay very high for the whole season, and the yield has not been so good because of drought in all over the Western Europe. But we didn't see this movement. To my mind, what is it's not simply an economic issue. What is going to induce the movement is that all our societies will have to take completely on board the fact that the climate change is critical, and we have to address this critical issue altogether. And again, agriculture, because it is completely, it will have to adapt to the climate change, and we see how difficult it is. It is producing really a lot of greenhouse gas. The GPD from agriculture in Europe is 3%, with 20% of greenhouse gas. If tomorrow there is a kind of tax system on the greenhouse gas, agriculture is going to be in a very bad position. So we have to address that. And as I showed you, the key element is the nitrous oxide. So it's not a CO2 problem. It's not a CO2 problem, for instance, for fertilizer production. The key problem is the nitrous oxide produced because you put nitrogen, extra nitrogen in the system. And I think agriculture have to address that. Researchers have to address that. And we must, it's not the only objective for legume, but we must have in mind what is the contribution of legume to reducing this tremendous environmental impact. For me, this is the key challenge. All the other challenge, we have already met that in the history of mankind. Meeting a war, unfortunately, humans tend to go to war quite easily. Lack of production, this is something that has been addressed in the past. The climate change, the rhythm we have today, has never been addressed. It has never been met. And I think that we have to go for that. And legume is, because at the very heart of that, there is nitrogen. Legume is the only answer, or it's not the only, not the only, but it's one of the key answers we have to work on. At least this is my kind of, I will not say a testimony, I'm not dead yet, but it's clearly something, that is, we didn't put this at the right level in our agenda. We have to put this a bit higher in our agenda.
Okay. Are there any other questions? Okay, so I'm going to stop recording, not before having thanked again Christian. and all of you for being here for the for this first meeting. It has been very interesting, and I hope to hear again from some of you, especially given what we talked about. It would be interesting if this could be also a starting point for talking to each other and doing networking, since we all more or less are interested in legumes. So I ask you if you're interested. We have a few public connection points. We have a Twitter account, there is the website, there is, I recently published on ResearchGate a new project on the webinars. More or less, if please try to keep in contact, especially if you have questions, if you have new ideas that could be implemented, because as Christian explained, we need some action at this point, at this specific point of history. So thanks again. And this is the end of our recording.